Hello, I'm Kirk Weiler. Welcome to another Common Core Algebra 2 lesson by eMath Instruction. Today, we're going to be doing one of our add-on lessons, specifically Unit 6, lesson number 5.4, on factoring trinomials using the AC method of factoring. We'll talk about why it's called the AC method of factoring. You may have seen this before. Maybe your teacher even showed it to you back in Algebra 1. And there is a reason why it's kind of given that informal name. But let's take a look at why this method even comes up, not how to do the method yet. Factoring trinomials, i.e. breaking up a three-term polynomial into the product of two binomials, can be exceptionally difficult for students by using the guess and check method. Now, I love the guess and check method. I think it's extremely nice because you can always know whether your factoring is right or wrong. The problem with the guess and check method is that you have to guess, a product, and then check by multiplying it out, guess another product, check, etc. And that might not be so hard, especially if the leading coefficient is the number 1, not the number 18. Once this leading coefficient is something other than 1, guess and check can be quite hard. In fact, if I were to guess and check on this polynomial, all of these would be reasonable guesses. All of them would be reasonable. And again, this would be reasonable because 3x times 6x is 18x squared, and negative 10 times positive 2 is negative 20. And again, in each one of these, it's the same way. They're all reasonable guesses, and they're all wrong, right? If we kind of worked them all out, none of them would give us a linear term of positive 9x. In fact, the correct one is this, 6x minus 5 times 3x plus 4. All right? And it might take me 3 or 4 guesses to find that out. And a lot of times students don't like that. They'd like a method with a trinomial that will allow them to factor something and get it right on the first time. So let's actually see what that method is. Now, before we can get into the AC method proper, we have to actually review factoring by grouping. Now, this is a technique you're already supposed to know, and if you don't know it, then you don't particularly want to maybe watch this particular method. It becomes more difficult. But you probably could still get away with it. Still, what I'd like you to do, since in theory that this is a review problem, I'd like you to take a moment and try to factor each of these two into the product of two binomials. Take a moment to do that. All right, let's go through it. Now, the first one should be relatively easy because what we can see is that x minus 5 is a factor of both this and a factor of this. Maybe make this a little bit smaller. All right. So what I can do is I can pull an x minus 5 out of both of those. And what I'm left with is a 4x here. And this is mildly hard to see, so let me get rid of it. And a minus 3 here. And that's it. Oh man, was that easy, right? Because that x minus 5 was just sitting there. On the other hand, this one's a little bit trickier, and remember how factoring by grouping works. Typically, you take a look at this first binomial pair and you try to factor out a GCF. Now, between 12x squared and 6x, a very simple GCF that we can factor out is 6x, leaving us with 2x minus 1. Then, when we look at this binomial pair and we say, all right, what can I factor out of 14x minus 7? I can factor out a positive 7. And when I do that, I'm left with 2x minus 1. And now, this particular expression is very similar to this one, i.e. we have this common binomial factor, 2x minus 1, right? In this case, it's being multiplied by 6x. In this case, it's being multiplied by positive 7. So I can simply factor out that 2x minus 1 and have it multiply 6x plus 7. All right? Now, these two, especially this one, is going to be sort of the end result of being able to factor using this AC method. So make sure you understand this before we move on. All right, let's learn the AC method for factoring trinomials. Okay, here we go. Consider the trinomial 4x squared plus 5x minus 6, which is written in the form ax squared plus bx plus c, right? A, B, and C from the quadratic formula, from general work with parabolas and things like that, A, B, and C. Now, let's take a look at letter A. It says find the product of A and C, and we're going to just walk through this entire problem together. Find the product of A and C. Well, in this case, A is equal to 4, C is equal to -6, so A times C, really easy, is -24. All right, that's simple enough. Then find two numbers whose sum is equal to B and whose product is equal to A times C. So the sum is equal to B, which is equal to 5. All right, this is the hardest part of the AC method of factoring. We now have to use our brains to try to find two numbers that have a product of -24 and have a sum of +5. I'd like you to pause the video for a minute and see if you can do that. Come up with two numbers whose product is -24 and whose sum is 5. All right, well, a little hint on this. Obviously, if the product is negative, one of the numbers needs to be positive and one of the numbers needs to be negative. That's the only way you're going to get a product that's negative. On the other hand, because the sum is positive, that means of these two numbers, the larger one must be positive or you would have a negative sum, all right? Now, the two numbers that get the job done are 8 and -3, right? If I do 8 times -3, I get -24, and if I do 8 plus -3, I get +5. All right, but what do we do with those two numbers? And again, that's the hardest part of this method, is just finding these two. So now, what do we do? Well, letter B says, rewrite the trinomial's linear term, that's the 5x, using the two numbers you found in A. In other words, right, we can rewrite this 4x squared plus 5x minus 6. We can write this equivalently as 4x squared plus 8x minus 3x minus 6. So we're going to take that linear term, that term with the b, and we're going to always break it up using these two numbers. We're going to kind of split up that 5x into 8x minus 3x, or you could think about it as 8x plus -3x, whichever is easier for you to think about. All right, now let's take a look at letter C. It says factor the trinomial from B, this thing now, using factoring by grouping. So now we can take our 4x squared plus 8x minus 3x minus 6, which is, again, algebraically equivalent to the original trinomial, and we can factor it by grouping. We're guaranteed to be able to factor it by grouping now. Isn't that kind of cool? So just like in exercise number 1, we can take a look at this binomial, and we can factor out a 4x, and that'll be 4x times x plus 2. Now this is a little bit tricky. Here, what we're going to want to do is we're going to factor out a -3, and we'll also have an x plus 2. And this is where, if you've done our lesson on factoring by grouping, that's a common manipulation that the second binomial you have to factor a negative out of. But once we have it like this, then we can do what we did before, factor out that common x plus 2. My mystery red pen. We'll just leave it that way. And we get x plus 2 times 4x minus 3. Now, just like the guess and check method, it doesn't hurt to actually check this to make sure that it actually works out to be correct, right? And it says check that the factor is correct by multiplying the two binomials to ensure their product is the original trinomial. All right, maybe this time we won't have the red show up, but I just want to do my check. So I'm going to do my my FOIL, so I'll get 4x squared, I'll get -3x, positive 8x, minus 6, these two combine to give me 4x squared plus 5x minus 6. Yep, check. All right, now you might say to yourself, wait a second, it's almost like doing the exact reverse of what we did here, right? Here we've got this, and once we do our foiling, first, outer, inner, last, right, we get that -3x, that positive 8x, which is exactly what we had here, -3x, positive 8x, just kind of written in different order, but that's that whole commutative property of addition. And then we see that when we combine all like terms, we're back to our original trinomial, which means that this is the correct factorization of the original trinomial, this guy. So it's a really cool technique because unlike guessing and checking, which is good and you should definitely work with it, it builds up your number sense and all sorts of great stuff. But unlike guessing and checking, if you can find these two numbers, the two numbers that have a product of A times C, that's why it's called the AC factoring method, and a sum of B, all right, then what happens is taking these two numbers, you can split that linear term up, and then you can use factoring by grouping to finish it off. All right, it's a fantastic technique. So let's get some more practice with it. All right, exercise number 3. Let's read through it together. Consider the trinomial 6x squared plus 19x plus 10. Factor this trinomial using the AC method. Check to ensure you've factored correctly. All right, let's go through the method again because I want to make sure that you see me do it at once again. Here's how you always start the AC method. You take A and you take C. Right, that's my product, and you get 60, right? So 6 times 10, right, 60. B is always my sum, and that's 19. Now again, this is the hardest part. You have to get this right, otherwise the whole method will fall apart. I am now looking for two numbers that have a product of 60 and a sum of 19. And notice both of these are positive, and that's important, right? Because to have a product of positive 60, right, means you could have two numbers that are positive, or you could have two numbers that are negative. But because the sum is positive, it means that the two numbers that give us this product must be positive. Now, what I'd like you to do is at least try on your own to do the hardest part of this, which is to come up with the two numbers. Pause the video now and make an attempt at it. All right, let's go through it. Now again, there are a lot of selections for 60, right? Could be 1 times 60, 2 times 30, 3 times 20, 4 colon 15, 4 times 15, 5 times 12, etc., right? 6 times 10. Actually, I think that's it. I don't know why I need the ... anymore. Now, of course, 1 plus 60 is 61, 2 plus 30 is 32, 3 plus 20 is 23, 4 plus 15 is 19. There it is, right? And you can do that off to the side. You can do, 1 plus 60 is 61, 2 plus 30 is 32, etc. But this is my winner. 4 plus 15 is 19, all right? So now what I'm going to do is I'm going to take my 6x squared plus 19x plus 10, and I'm going to make it into an equivalent 6x squared plus 10x plus 6x. Whoops, no, that's wrong. My apologies. Why am I doing that? My two numbers are 4 and 15, so let's do plus 4x plus 15x plus 10. And again, all I've done is taken that 19x and broken it into a 4x plus 15x. I mean, 19x could be broken into 1x and 18x, or 10x and 9x, but these two will allow us to now factor by grouping. So I now look at 6x squared plus 4x. I can factor a 2x out of both of those, leaving me with 3x plus 2. Here I can factor a 5 out of both of these, leaving me with 3x plus 2. Again, if I've done everything right, we should have a common binomial factor here and here, which we do, 3x plus 2. And therefore, we get 3x plus 2 times 2x plus 5. All right, and that should be the correct factorization. We can easily check. All right, but it's funny because the check here is literally going to just reverse these steps. In other words, if I do my foiling, I get 3x times 2x, which is 6x squared. I get 3x times 5, which is 15x. I get 2 times 2x, which is 4x. I get 2 times 5, which is 10. That gives me 6x squared plus 19x plus 10, and that checks then. Now keep in mind, this is the final answer. This is my factorization. This is simply my check. All right? Let me step back, you take a look, scroll up a little bit, all right, and then we'll move on to get some practice. All right. Now, oftentimes with algebraic techniques, there's a, but what if? What if, right? There's basically only one what if in this technique, okay? And that's if the trinomial contains a greatest common factor. And if it contains a greatest common factor, you want to be a little bit careful with this because oftentimes we want to factor something completely, meaning that it's as factored can get. And again, it's important, right? It's important to like really understand what complete factoring is. If I took the number, let's say 20, and I said factor it, and you said, oh, that's 2 times 10, well, that's great. You factored it, but it's not completely factored because 10 itself can be factored, right? So then if you did 2 times 2 times 5, that would now be 20 factored completely, right? So now, let's take a look at this. Consider the trinomial 6x squared minus 33x plus 36. Letter A says, what product must you use to split apart the linear term in this trinomial? Why does this make the problem difficult? So again, just what would be the product you'd have to work with? Well, the product that you'd have to work with would be 6 times 36, right? Which would be what? 6, 36, 18, 216. That would be the product, right? We'd be, maybe move this 6 a little bit closer so it doesn't look like 21 with a 6 sitting by it. How about 216, right? Just making sure. Okay, 216, right? We'd have to find two numbers with a product of 216 and a sum of negative 33. And again, this is just a kind of make sure you get it question. Why does this make the problem difficult? Well, because 216 is relatively large, right? We'd have to sit around and really kind of think, all right, well, let's see, 1, 216, 2, 100 and, whatever, I'd have to think about it a little bit, 108, right? You'd have to go through and come up with all these different pairs, right? And then they have to sum to negative 33, all right? Letter B. Show that the two numbers needed for letter A would be negative 9 and negative 24. Well, the way that you would show that these two numbers are the ones that are needed is by saying, well, negative 9 times negative 24 is in fact negative 200, is positive 216, and negative 9 plus negative 24 is negative 33. So yeah, those are the two numbers I need. They have a product of 216. They have a sum of negative 33. Now you might ask, why did he just give me those instead of make me work for them? Well, and the reason for that is that I don't want you to spend your time working on these. All right, and we'll eventually talk about why in just a moment. But for right now, we've got our two numbers. You didn't have to sit around and work on them. Letter C says, using the numbers from B, factor this trinomial using the AC method. Well, why don't you go ahead and try that? Here are your two numbers, negative 9 and negative 24. Factor this trinomial using those two numbers. Pause the video now and take a few minutes to do it. All right, let's go through it. Here we go. Come on, scroll up there. So what we're going to do is we're going to take this trinomial, 6x squared, and I'm going to break it into minus 9x, minus 24x, and then plus 36. Okay, great. So I've broken down my linear term into negative 9x, negative 24x. Now let me do my GCF factoring. Here I can pull a 3x out, and I'll end up with 2x minus 3. Here what we can do is we can, what can we pull out? We can pull out a negative 12, and that will give us 2x minus 3. Okay, again, I need to have those two binomial factors the same. So now that'll leave me with not a lot of room to write, 2x minus 3 times 3x minus 12. And actually, let me put it right up here. 2x minus 3 times 3x minus 12. All right, letter D. Why is your answer from letter C, in other words, this thing, not factored completely? Finish factoring it. So take a look at this. This is not factored completely, just as this, 2 times 10, wouldn't be factored completely. Why is this not factored completely? Well, the reason it's not is that this can be still factored, right? 3x minus 12 has a GCF all by itself, that GCF being 3. And in fact, I can factor that out. Nothing would happen to the 2x minus 3. But if I factored a 3 out of this, I would be left with x minus 4. So that would be that. Now again, you might say, well, why didn't the 3 sit right here? Well, because it looks strange, honestly. 2x minus 3, then having a 3 sitting between the parentheses and then the x minus 4 is just generally not the way they're written, all right? But if you think about it, you're pulling the 3 out of here, and you now have the product of 3 things. Since multiplication is commutative, the order in which you write it does not matter. All right? So, we don't want to have to guess these huge numbers. We don't want to have to do it. So what we want to do in a situation like this is we want to see this trinomial, and we want to say, hey, wait a second. 6, 33, and 36 all have a common factor of 3, and I want to factor that out first, okay? In other words, I want to take this thing and get this 3 out of the problem. And when I factor that 3 out, I'm left with 2x squared minus 11x plus 12, right? So I factored that 3 out. Now what I have to do is use the AC method to factor that. Right? So I might go like this. Well, let's see, I've got a times c is equal to 24, b is equal to negative 11, right? What are my two numbers? Well, they have to have a product of positive 24, but a sum of negative 11, and those three numbers would then be negative 3 and negative 8. And again, let's just pause for a second here. Negative 3 times negative 8 is positive 24, and negative 3 plus negative 8 is negative 11. I said positive 11. All right, so now I'm going to take those, and I'm going to take this 2x squared minus 11x plus 12, and I'm going to break it into 2x squared minus 3x minus 8x plus 12. All right, from here I can factor out an x, and I'll be left with a 2x minus 3. From here I can factor out a negative 4, which will leave me with a positive 2x minus 3. There's that 2x minus 3. So that will leave me now with x minus 4 times 2x minus 3. Now you have to be a little bit careful, because you might think, oh, there's my final answer. But keep in mind, that's just what this is factored. We can't lose that 3. We just can't lose it. So we need to make sure that we don't forget it. That is my final answer, which is, of course, exactly what I got up here. The big difference is the following. By factoring that 3 out, we're left with two numbers here, 24 and negative 11, that are much, much easier to deal with than what we had up here, right, with 216 and negative 33, right? 216 and negative 33 versus 24 and negative 11. Much easier to think about these numbers. Factor that GCF out first, if there is one. If there is one. If there isn't one, great. Then you just go with your product, your sum, and you move on. Okay? Speaking of which, let's get some practice. So I've got two practice problems here. We want to factor both of them using the AC method. One has a GCF and one doesn't. What I'd like you to do is work through both of them, pause the video, take as much time as you need, and then we'll come back and we'll go through them both. All right, let's do it. Exercise number 5, gain additional factor, practice factoring. Let's do it. So letter A, right? The first thing I want to do in these problems is look at that 4, that 17, and that 15 and go, are there any common factors? And the answer hopefully immediately is no. 17 is a prime number, so it has no factors other than itself and the number 1. Kind of boring, but that is what it is. So immediately what I'm going to do is I'm going to do my A times C, right, which is 4 times negative 15, and that's negative 60, so there's my product. And B, my sum, is negative 17. Now again, keep in mind, a negative product and a negative sum means you've got a positive and a negative, right, that are multiplying here. On the other hand, right here, it means that the negative portion of this product must be 17 units larger than the positive portion. And again, you could kind of sit here and you could, forgetting about the positive and the negative, we've already looked at 60 already, 2 times 30, 3 times 20, 4 times 15, etc. This is actually sort of my winner, 3 and 20. Now it's not 3 and 20, it's actually 3 and negative 20, right? Those are my two numbers. 3 times negative 20 is negative 60, and 3 plus negative 20 is negative 17. So now let's do the factoring in this nice wide open space over here, right? So now we're going to take our 4x squared and we're going to make that negative 17 into a negative 20x and a positive 3x. Don't forget these x's. I should have pointed this out long before now, but one of the major mistakes people will make is they'll get this negative 20, this positive 3, and then they'll put them in here without the x's. Without the x's, it becomes extremely hard to sort of like factor these in any kind of a reasonable way. But now let's tackle this. All right, 4x squared minus 20x, we can factor out a 4x, we'll be left with an x minus 5. Here we can factor out a 3 and we'll be left with an x minus 5. We've got that common factor of x minus 5 now, so we'll factor that out. And we'll be left with this. One of the great things about the AC method of factoring trinomials is it all really boils down to how good are you at factoring GCFs, right? That's it. Greatest common factors. So if you're good at factoring out GCFs, then this is a fantastic technique, right? And it also gets you that answer to the trinomial factoring on your first shot. You don't have to guess and check, guess and check. What you might have to do is guess and check to find these. Hey, you got to spend the time somewhere. Let's take a look at the next one. Now, these two I tried to make very similar in the sense that the leading coefficient was 4. But one of the big differences now is when I look at this, 4x squared minus 30x minus 16, what I note is that each one of these numbers is divisible by 2. It'd be great if they were all divisible by 4, but we don't get so lucky with the 30, all right? But I can factor out a 2. And when I do that, I'll be left with 2x squared minus 15x minus 8. Now again, you could begin by just doing 4 times negative 16, etc., but there'll be a GCF in there that you'll have to catch at the end. I always think it's easier to pull it out at the beginning, all right? And now I can do my product. My A times C is negative 16, and my B is negative 15, okay? And this can actually be quite tricky for people because they're sitting and they're looking at that 16 and they're thinking 4 times 4, 2 times 8, nothing's kind of panning out. But the two numbers that'll work will be negative 16 and positive 1, right? Negative 16 times positive 1 is negative 16, and negative 16 plus positive 1 is negative 15. So I can now take my 2x squared minus 15x minus 8, and I can make it into 2x squared minus 16x plus 1x minus 8. Now again, this can be a little tricky for people. When I group this and I factor it, I'll pull out a 2x and I'll be left with x minus 8. But what do I do here? Well, what I can do, which is kind of a neat almost sleight of hand, is I can rewrite this as 1 times x minus 8. Right? Now I can see, that x minus 8 is multiplying both a 2x and the number 1. So I'll be left with x minus 8 times 2x plus 1, and I can't leave off my GCF. Otherwise, I haven't factored it completely. And there it is. All right? Take a moment on this one in case it was confusing, and then we'll wrap up the lesson. All right, let's do it. So, there are major factoring techniques, and one of them is, of course, the factoring of trinomials. This is one of the most frustrating topics for a lot of students because if they're using the guess and check method, they have to guess, they have to multiply out the two binomials to see if it's equal to the original trinomial, guess again if they're wrong, again if they're wrong. Now eventually with guess and check, if you work with it enough, you get to develop a lot of good number sense, good ability to multiply out two binomials. There's a lot of great side benefits to the guess and check method. But students tend to dislike it because it can take a long time. On the other hand, this AC method of factoring allows us one method of factoring a trinomial correctly on the first shot. The big drawback to the AC method is that you actually have to find these two numbers that have a product of A times C and a sum equal to B. But once you have those two numbers, then generally speaking, this AC method of factoring basically boils down to, can you factor out GCFs? And if you can factor out GCFs, The technique is fantastic and easy and nice to use. All right, so I hope that this was a good addition to the Common Core Algebra 2 curriculum. You can now use this technique in future problems in the course, and there's going to be lots of problems that involve factoring. One way or another, whether you use guess and check, factoring trinomials, or the AC method, you've got to get good at it. All right. Well, thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.